Hi everyone, welcome back to the channel. And today we're going to solve Leetcode daily challenge. Problem number 2092. Find all people with secret. So it's an interesting problem to solve, and it is tagged as a hard problem, and it indeed is. So we'll first check out the problem statement, then we'll look into the approach which we're going to use, and towards the end we'll see the code as well. So let's start with the problem statement. It is given that we'll get an integer n indicating there are n people numbered from 0 to n minus 1. You're also given a zero indexed 2D integer array meetings where every element in meetings represents a array with three values xi, yi, and timei. So this represents x and y have a meeting scheduled at time I. A person may attend multiple meetings at the same time, and finally you are given an integer first person. Okay. Person 0 has a secret, so this is by default. Person 0 has a secret and initially shares a secret with the first person. It can be anyone, like it can be 1 2 3 4 whatever, like it can be anything. At time 0, the secret is then shared every time a meeting takes place with a person that has a secret. Okay. More formally, for every meeting, if a person xi has a secret at time ti, then they will share the secret with person yi and vice versa. So basically, if any of the person who is in the meeting have the secret, so they can share that among each other. The secrets are shared instantaneously. That is, a person may receive the secret and share it with people in other meetings within the same time frame. So for example, we were allowed to attend multiple meetings at the same time. So this is an extension to that if he got to know about the secret from one call, he can share that the same secret in the other call. At the end, we have to return a list of all peoples that have the secret after all the meetings have taken place, and the answer can be in any order. Okay, sure. So basically, we have to figure out. Also, I would suggest that you should go with the examples first before start to solve this problem, because it gives you a better insight of what exactly has been happening. So let's directly move towards the approach which we can use to solve this question, and I'll explain you what we will be doing over there. So first of all, we will be using a DFS approach to solve this question. And what I will be doing first is I want to make this data more interpretable for me. So to do that, what I will do, I'll prepare a graph-like structure for me. Okay, in which I'll read all these uh, elements, all these sub-arrays. For example, one have all these meetings with other person at a certain time. So for example, one has a meeting at 5 o'clock with person 2, and one has another meeting at 10 with 5. Okay. Similarly, I'll be keeping a track of 2, so he has a meeting with. Also, one more thing, like these are bi-directional communication, so they can have the you know uh, they can have the values or these elements common within the two keys. Similarly, 2 has another meeting at 8 with 3. Okay, and the last record is for 5. There will be 3 as well, because we used 3. So let me put it. So it is 8 and 2, and for 5 it will be what, 10 comma 1. Okay, so we have all these meetings. Now I want to keep a track of when a certain person came across the secret. So let's keep a variable earliest. Okay, in which we will all the index, basically 0 1 2 3 4. So all the indexes basically will tell you, I think there will be 5 as well, because n is equals to 6. Okay, so this is 5, and every index will tell you when was the earliest person at index I came to know about the secret. For example, 0, it will be always 0, and for example, in this case, first person is 1. So for the first person, it will be 0 again, because he got to know about this at the very uh, at time 0. Okay. Now for 2, there are two meetings. Okay. First one is happening at 5 and another one is happening at 8, and he can get to know about the secret at 5. But for now, we will put infinity for all the other person in the array, because we don't know when they got to know about it. Okay. Next is what I will do. I for sure know that I'll be using a stack for the DFS. Okay, and this stack will have first 0 0, because of course, like 0 knows about his secret and it started at time 0, and there will be another one which will be, sorry, first person is 1 and 0. Okay, this is my current stack now. Okay, now what I have to do, and one more thing, this number basically represents the person and this represents the time. Let write that. Okay, now I'll pop one element, okay, from the stack top. For example, we'll start with this. Let's say, it's the other way around, we start with 0 0. Okay, just for the simplicity. Now I will check uh, what all. There will be one more point in here. Okay, yeah, so let's start with this. I want to keep it simple. So as soon as I get person and the time value, I will check what all other person I can reach out to or I had meetings with, and at what time. For example, we received 1 0. We are processing 1 0 right now. Okay, so first option is I can reach out to P2 will be 2 and T2 will be 5. Okay, so treat this as P1 T1 P2 T2. Okay, now I would like to check if this meeting is happening after 1 came to know about the secret or not. Okay, because that's only when we will be able to share the secret with second. Okay, so the first condition is T2 should be greater than or equal to T1. We can also share the secret instantly as well. Okay, and there is one more condition. The condition is that earliest of next person basically is P2. Okay, earliest of next P2 should be greater than T T T2 now. Okay, because that's only when we are making sure that, okay, we have not already processed this person. So basically we don't want to process it again and again. We don't want to process the same person again and again. If these two conditions satisfies, then we will first update the value of P2, like in the earliest array, with T, which is our T2. Okay, because this is the latest time we got, and we will add this combination, which is your next person is P2 and T2 in our stack. So now it has let me do this, it has what, 2 and 5. Okay, there is one more point, there is one more person which we can reach out to via 1, which is 5. So we will use the same method and we will check if we can reach out to him or not, and similarly he will also be added in the stack. So if you see what we are doing over here, we are just reaching out to or we are just adding those person and the time who will know about the secret, and we are not processing any other person who won't be able to know the secret. Okay, so this is the approach we should be using. So let's check out the code as well. Okay, it's a simple code. What we are doing is, as I mentioned, we have prepared a graph. Okay, and it's a bidirectional graph. That's why we are making entries in for both the persons. For example, if there is a relation with if two persons x and y have a meeting at t, then the entries are being made in both the for both the keys, I should say. Okay, so this is where we are preparing our graph as we discussed in the explanation. Next is the earliest you know anyone came to know about the secret. So this will be an array. We have initialized it with infinity, and it will be of size n, of course. After that, as we know, like the earliest for zero will be zero, because he always zero always knows about his secret, and he shared the secret with first person at time zero. So that's why we have to update the earliest for these two person with zero. Next, we have defined our DFS function, in which we are taking two parameters, person and time. Okay. Next is we are checking who can be reached out via person. Who else? For example, if we have one, uh, we have already shared the secret with one. Who else he can share the secret with? Okay. So for that, we are using our graph to check, the meetings person one will have with anyone, and we are getting two values, that is time, at what time it will be, and who will be the person he'll be meeting with. Okay. If the next meeting is greater than equals to time basically represents when he came to know about the secret. Okay. If the meeting is later than when he came to know about the secret, later or at the same time, and earliest of next person, that is the next person who he will be meeting with has a greater time of of at which he will be meeting with. Okay. So for example, next person was person 2. Okay, initially he had infinity. Okay, so he of course doesn't know about the secret. Okay, and we will check if, okay, what if at time 2 we share the secret. Okay, so this is the condition to do that. If both these conditions are getting true, then we are updating the time of next person with the current time, like the time of meeting, I mean to say, and we will add that in the stack. We are recursively calling the DFS function for that. Okay. At the end, we are just simply initializing with 0 0. This will be the first, the 0th person who has a secret, and the first person he shared with. After that, at the end, what we are doing, we are making an array of all the indexes whose um, earliest value is not equals to infinity, and those will be the answer, because we have only processed the persons who came to know about the secret. Okay, so this was the code. Let's check out the test cases. And as you can see, all the test cases got cleared. Also, one more thing, you will see three test cases over there, but I added one more because I was initially trying to solve this problem using union find, but it was getting a little tricky, so that's why I opted for a simpler approach. Let's submit it for further evaluation. And by the way, as a you know as an interesting problem, you can also try to solve this problem using the union find. It will be an awesome exercise. So as you can see, the solution got accepted, and I would say we have performed fairly well. So yeah, this was the solution, guys. Thanks everyone for watching other videos. Stay tuned for the upcoming ones. Don't forget to like the video and subscribe to the channel. Thank you.